Good evening, students. So today I am taking a class of gravitation. So you'll see what are the basic concepts and the laws associated. You'll see this. First of all, in the chapter of gravitation, we have the very first thing is what key there are some theories, like one is the geocentric theory. So geocentric theory is what, you know that theory is not right, but the theory is what it is. Earth is at the center of the universe, and including sun, all the planets revolve around it. So you know this is not right. This theory, this is given by what? This is written in the Bible. जिसका जो सोर्स है that is what? चर्च का ये मानना था कि अर्थ यूनिवर्स का सेंटर है और इंक्लूडिंग सन, बाकी सारे प्लैनेट्स अर्थ के चारों ओर रिवॉल्व करते हैं. तो यू नो दैट वाज नॉट राइट, ये गलत था. फिर इसके बाद जो थ्योरी आई दैट वाज अ हीलियोसेंट्रिक थ्योरी. तो हीलियोसेंट्रिक थ्योरी जो थी, इस थ्योरी के अकॉर्डिंगली क्या था? सन इज द सेंटर ऑफ आवर solar system. Sun is the center of our solar system, and including Earth, all the planets revolve around it. तो अर्थ और बाकी सारे planets सन के चारों रिवॉल्व करते हैं. दैट वाज द थ्योरी, एंड दिस हैड गॉट द साइंटिफिक बेसिस. जिन्होंने ये थ्योरी प्रमोट की, देवर द गैलीलियो, कोपरनिकस. दो क्योंकि उस टाइम पे चर्च वाज रूलिंग ऑलमोस्ट द एंटायर वर्ल्ड, तो था क्या कि दोज पीपल वर टॉर्चर्ड ऑल्सो. ये जब जॉर्ज कोपरनिकस और गैलीलियो ने बताया, सो यूजुअली दैट वाज द बिगनिंग ऑफ द साइंस एरा. That was the beginning of the science era and the science revolution. तो स्टार्टिंग में क्या होता था कि anything that was established by church or such other authorities, कोई भी चीज़ उनके अगेंस्ट आती थी, they immediately did what? They tried to suppress it. क्योंकि उससे क्या होता था, उनकी बातें झूठी साबित होती थी, जो कि इस्टेब्लिशमेंट के अगेंस्ट था. ठीक है ना? सो जो ये थ्योरी करेक्ट थी, जो अभी भी है, एंड दैट इज़ ट्रू ऑल्सो. सन सोलर सिस्टम का सेंटर है हमारे, एंड इंक्लूडिंग अर्थ ऑल द प्लैनेट्स रिवॉल्व अराउंड इट. इसके बाद वन ऑफ द मोर साइंटिफिक वर्क वाज डन बाय केपलर. एक साइंटिस्ट थे केपलर. तो जो केपलर है, केपलर्स लॉज, और केपलर्स लॉज आर वेरी साइंटिफिक लॉज. उन्होंने अपनी लॉज के बेसिस पे जो पूरा सैटेलाइट का मोशन है, जैसे मून इज़ ए सैटेलाइट, नेचुरल सैटेलाइट ऑफ अर्थ, और द मोशन ऑफ ए प्लैनेट अराउंड द सन, everything was well explained on the basis of these laws. And when Kepler had given these laws, Kepler was himself a student. Kepler ब्रिटेन की किसी यूनिवर्सिटी में स्टूडेंट थे, और ये लॉज भी उन्होंने कैसे दिए? ये जब लॉज उन्होंने दिए तो बिफोर दैट इन द यूनिवर्सिटी ही हैड ऑब्जर्व फ्यू थिंग्स. उन्होंने कुछ चीज़ें टेलीस्कोप से ऑब्जर्व की थी, उसके बेसिस पे ही हैड जनरेटेड डेटा. और देयर वाज सम कॉलरा एपिडेमिक इन द हॉस्टल, और हॉस्टल्स को इवैक्यूएट करा करके उन्हें घर भेज दिया गया स्टूडेंट्स को. तो जब केपलर वेंट बैक टू हिज होम, देयर ही मेड दीज लॉज ऑन द बेसिस ऑफ दोज एक्सपेरिमेंटल फैक्ट्स. द डाटा दैट ही वॉज हैविंग विद हिम, उसके बेसिस पे ही गेव दीज लॉज एंड दे आर येट वैलिड एंड विल ऑलवेज बी वैलिड। यू सी केपलर्स फर्स्ट लॉ इज व्हाट, आई एम स्पीकिंग बट नॉट राइटिंग, आई विल एक्सप्लेन। ठीक है ना, अब जब आप अपने नोट्स रेडी करेंगे सो यू कैन सेपरेटली राइट दोज, यू कैन मेक द नोट्स। ठीक है ना, दोबारा से रेडी करना, मैं बोलूँगा और मैं एक्सप्लेन भी करूँगा। केपलर्स फर्स्ट लॉ वाज कि all the planets are revolving around the sun in the elliptical path. Ellipse is what? This is an elliptical path. So all the planets are revolving around the sun in the elliptical orbit. एक ellipse में दो फोकस होते हैं। अभी आपको what is a focus जानने की ज़रूरत नहीं है, but you should know एक ellipse में दो फोकस होते हैं। So he said the path of the different planets is elliptical around the sun. And it is elliptical in such a way that the one focus of all the elliptical path is what? Common. जितने भी planets के elliptical orbits हैं, ठीक है ना, this is planet P1, planet P2, planet P3. So all the elliptical orbits, they have one focus at the common place, and that common focus is what? There is a place of sun. यहाँ पे sun होगा। तो आपने ज्योग्राफी की बुक में यू माइट हैव सीन दिस काइंड ऑफ ए फिगर, सो दैट रिवील्स व्हाट कि ऑल द प्लैनेट्स हैव वन पॉइंट कॉमन, दैट इज व्हाट देयर फोकस इज एट द सेम प्लेस एंड एट दैट सेम प्लेस इज व्हाट सन। दिस इज द फर्स्ट लॉ। नाउ सी द सेकेंड लॉ, केपलर्स का जो सेकेंड लॉ है दैट इज व्हाट केपलर्स सेकेंड लॉ इज, इट्स इंटरेस्टिंग लॉ। दिस इज अ लॉ ऑफ एरियल वेलोसिटी, एरियल वेलोसिटी। यू सी the law is what? Law of aerial velocity is this. Suppose this is the path of a planet. ये एक planet का path है, this is the sun. ये planet का path और ये sun है। Planet was at this position P1. It reaches from P1 to P2 in time delta t. So the line joining the sun and the planet, line joining the सन एंड द प्लैनेट स्वेप्ट दिस मच ऑफ एरिया, इसने इतना एरिया स्वीप किया। दिस द लाइन ज्वाइनिंग द सन एंड द प्लैनेट एंड इट स्वेप्ट दिस मच ऑफ एरिया, इतना एरिया स्वीप किया। प्लैनेट P1 से P2 तक पहुंचा इन टाइम डेल्टा टी, और लाइन ज्वाइनिंग द सन एंड द प्लैनेट स्वेप्ट दिस मच ऑफ एरिया, दिस एरिया इज डेल्टा ए। देन डेल्टा ए बाई डेल्टा टी इज कॉल्ड व्हाट? दिस इज कॉल्ड एरियल वेलोसिटी। इन द लॉ इज व्हाट? लॉ ये था कि जब प्लैनेट रिवॉल्व अराउंड द सन, इट्स एरियल वेलोसिटी रिमेन्स कांस्टेंट। एरियल वेलोसिटी रिमेन्स कांस्टेंट। एरियल वेलोसिटी रिमेन्स व्हाट? कांस्टेंट। इसकी एरियल वेलोसिटी कांस्टेंट होगी। एरियल वेलोसिटी कांस्टेंट का मतलब क्या हुआ? जैसे P1 से P2 तक ये डेल्टा टी टाइम में गया। नाउ फ्रॉम पॉइंट P3 टू P4 ऑल्सो इट गोज इन टाइम P4, इट गोज इन टाइम डेल्टा टी। यहाँ से यहाँ तक का भी टाइम डेल्टा टी है। तो जो एरिया स्वीप होगा यहाँ पे इक्वल टाइम में, जो एरिया स्वीप होगा, लाइन ज्वाइनिंग द सन एंड द प्लैनेट्स विल स्वीप इक्वल एरिया इन इक्वल टाइम। मतलब यहाँ का भी टाइम डेल्टा टी है, और ये एरिया अगर डेल्टा A1 है और ये एरिया डेल्टा A2 है, सो डेल्टा A1 विल बी इक्वल टू व्हाट? डेल्टा A1 विल बी इक्वल टू डेल्टा A2। मतलब दिस एरिया विल बी इक्वल टू दिस एरिया बिकॉज टाइम इक्वल लगा है। अब देखो आपके सिलेबस में एक पैरामीटर है, वो सिलेबस में नहीं है अभी, एंगुलर मोमेंटम, बट फिर भी क्या होता है समटाइम इन कॉम्पिटिशन्स दे आस्क द क्वेश्चंस विच इंक्लूड द पैरामीटर्स ऑफ नेक्स्ट क्लासेस ऑल्सो। सो अगर आपसे कभी किसी कॉम्पिटिशन में पूछा जाए कि दिस लॉ ऑफ केपलर इज बेस्ड अपॉन विच फंडामेंटल लॉ ऑफ फिजिक्स, सो दिस इज बेस्ड अपॉन लॉ ऑफ conservation of angular momentum. This is based upon what? Law of conservation of angular momentum. This law of physics, law of aerial velocity is based upon what? Law of conservation of angular momentum. जैसे अब आप बोलोगे लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम क्या है, एंगुलर मोमेंटम क्या है, कोई आपको जानने की भी ज़रूरत नहीं है। किसी भी लेवल के क्वेश्चन में NTSE, JSTSE, किसी भी ओलंपियाड में के कॉम्पिटिशन में इस लेवल पे अभी इसके जानने की कोई ज़रूरत नहीं है कि व्हाट इज़ एंगुलर मोमेंटम इन व्हाट इज़ द मीनिंग ऑफ लॉ ऑफ कंजर्वेशन, बस आपको पैरामीटर याद रखना है कि ये फिजिक्स का एक फंडामेंटल लॉ है जो कि आप आगे सीखोगे, और ये लॉ इसी लॉ पे बेस्ड है। देन सी केपलर्स थर्ड लॉ। यू सी केपलर्स थर्ड लॉ इज, जैसे मोस्ट ऑफ द कैलकुलेशंस, दो इन प्रैक्टिस दीज मोशन आर इन द एलिप्टिकल ऑर्बिट, ये मोशन कैसे एलिप्टिकल ऑर्बिट में है, बट क्या होता है, what laws are valid for the planetary motion, the same laws are valid for the satellite motion also. जो planetary motion के लिए वैलिड है वो सैटेलाइट के मोशन के लिए वैलिड है, और सैटेलाइट में कुछ एक सैटेलाइट का पाथ सर्कुलर भी है। सैटेलाइट्स का पाथ मतलब सर्कुलर ऑर्बिट के भी सैटेलाइट्स होते हैं, इन एलिप्टिकल ऑर्बिट के भी सैटेलाइट्स होते हैं। सो दिस लॉ इज व्हाट, फर्स्ट आई टेल यू दिस लॉ फॉर द circular orbit. Suppose there is a sun, I'm telling you it for the planet, and there is a planet which revolves in the circular orbit of radius r. So the law is what? T square is proportional to r cube, means what? T is the period of revolution. Period of revolution means the time in which it will complete one revolution. The time in which it will complete one revolution is the time period t. So that square of the period of revolution is proportional to r cubed to the radius of the orbit. It will be proportional to what? Cube of the radius of the orbit. T is the period of revolution. Period of revolution. Is that clear? It is proportional to r cube. If the orbit is not circular, the orbit is elliptical, then see, in the elliptical orbit, this is called major axis. This is called what? Major axis. This is called minor axis. Suppose the major axis is 2b. Suppose this 2b. Then period of revolution t square is proportional to b cube semi-major axis. This is a major axis 2b, so b is what? B is the semi-major axis. Half of the major axis is called what? Semi-major axis. T square is proportional to what? B cube. These are Kepler's law. You see, the emphasis in the examinations like JSTSE, NTSE is not much upon the Kepler's laws. The emphasis in all these competitions is much upon what part I'll be teaching you now. अब जो मैं बताऊंगा. But because Kepler's laws are very fundamental laws of this chapter, so that was necessary for me to tell you, to introduce you with these terms also. Otherwise कभी आपको पता लगा कि you got to know there are some Kepler's laws also, और आपने केपलर का नाम ही नहीं सुना, जबकि केपलर्स के laws were one of the most scientific laws, proven laws, जो कि इस चैप्टर में सबसे पहले laws थे जो आए थे. Now see, next is what? It is a Newton's law of gravitation. आपका स्कूल सिलेबस भी इस लॉ पे ज़्यादा फोकस करता है, न्यूटन्स लॉ ऑफ ग्रेविटेशन. सो सी, न्यूटन्स लॉ ऑफ ग्रेविटेशन इज व्हाट? द लॉ, यू नो, I'll be telling you the applications. Law is what? If there are two masses m1 and m2 separated by a distance r, there are two masses m1 and m2 separated by distance r, then the attractive force between them will be equal to capital G into m1 into m2 divided by what? R square. So if masses are in kg, distance is in meter, then capital G equals what? Capital G equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. और जो यूनिट है, यूनिट आप मगअप नहीं करोगे, आप immediately you can get the unit of capital G. How? Capital G क्या होगा? F into R square upon m1 m2. तो F का यूनिट हो गया न्यूटन, इंटू आर स्क्वायर, दैट विल बी व्हाट? मीटर स्क्वायर. m1 into m2 what? kg square, so that becomes 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the value of what? Capital G. So between the two masses you can always calculate that this is the attractive force. मान लो सपोज बोथ द masses are, ये जो लॉ है ये वैलिड कैसे कैसे है? जैसे बोथ द masses are particles, दोनों masses particles हैं, particles means very very small, तो लॉ इज वैलिड, तभी लॉ वैलिड है. दोनों स्फीयर्स हैं, मास m1 मास m2, रेडियस r1 रेडियस r2, सेंटर्स के बीच की डिस्टेंस r है, तो अभी भी फोर्स F क्या होगा, कैपिटल G m1 m2 डिवाइडेड बाई वॉट आर स्क्वेयर. स्टिल द लॉ इज वैलिड. जो लॉ है इट्स स्टिल वैलिड फॉर द स्फेरिकल मासेस. दिस इज ऑल्सो वैलिड इफ, अगर मानो कि सपोज वन मास इज वॉट m1 particle, one mass is particle, the other mass is what, spherical, mass m2, और m1 की distance from its center is what, r, then the इसकी radius कुछ भी हो, radius does not matter, radius whatever be the radius, distance between the center of the sphere and this mass is what, m1. In that case also attractive force is capital G m1 m2 by r square. Means what you should know is and what you do not know, जो तुम्हें जानना ज़रूरी है और जो तुम्हें नहीं आता है. दैट इज़ वॉट. ये लॉ ऐसा नहीं किसी भी ऑब्जेक्ट के लिए वैलिड है. सपोज आपको एक रॉड दी गई L1 लेंथ की, एक दूसरी रॉड है L2 लेंथ की. इट्स मास इज m1, इट्स मास इज m2. इसका मास m1 और इसका मास m2, और इनके सेंटर्स के बीच की डिस्टेंस क्या है, r है. इनके सेंटर्स के बीच की डिस्टेंस क्या है, r है. अब आपसे बोला गया इनके बीच का अट्रैक्टिव फोर्स. तो अगर आप करते हो कि कैपिटल G m1 m2 बाई आर स्क्वेयर, सो दिस रॉन्ग, ये गलत है. मतलब दिस इज एप्लीकेबल, लॉ एप्लीकेबल केवल किसके लिए है, पार्टिकल्स के लिए और स्फेरिकल मासेस के लिए. एक मास स्फेरिकल है, एक पॉइंट मास है, तब भी एप्लीकेबल है. ठीक है ना. नाउ सी ऑन द बेसिस ऑफ दिस वी फाइंड व्हाट, जो कि आपके लिए कॉम्पिटिशन्स के लिए बहुत ही इंपॉर्टेंट है. दैट इज व्हाट, द एक्सेलरेशन ड्यू टू ग्रेविटी. The acceleration due to gravity, what you call small g, आप क्या बोलते हो उसे, small g. ठीक है ना. that is what acceleration due to gravity. तो acceleration due to gravity different places पे जहाँ ना कि तुम्हें फॉर्मूले याद रखने हैं. they are what, अर्थ की रेडियस re, अर्थ का मास me, at the surface of the earth, at the surface of the earth. Remember, this small g will be equal to capital G mass of the earth upon what, re square. So how it is important and in what kind of questions do they ask? Suppose they give you not the value of g at the surface of the earth, the value of small g, acceleration due to gravity at the surface of some other planet, at the surface of the moon. Formula change कैसे होगा, capital G, it's a universal constant, mass of that planet upon square of the radius of that planet. जिस planet की बात करें, mass of that planet divided by square of the radius of that planet. moon के surface की बात होगी, so mass of the moon divided by square of the radius of the moon. That will be what, it will be the value of small g at the surface of the earth. ठीक है ना. अब अर्थ के सरफेस से h अंदर, at this point, the value of g inside the earth, h distance अंदर, g will be equal to what, g dash, it will be, मैं अर्थ के what is the value of g at the surface of the earth, इस g के टर्म्स में बताता हूँ. it will be g into 1 minus h over re. This will be what, 1 minus h over re. This will be the formula where small g is what, small g is the acceleration due to gravity at the surface of the earth, और g dash h depths पे अंदर क्या होगा, g into 1 minus h over re. This will be the value of what, g dash surface के अंदर. इससे देखो you can find one conclusion that g dash at the center, center पे क्या होगा, at the center क्या होगा, 0. How it will be 0? Look at this. h at the center, h becomes what, re. At the center, h becomes what, re. h is the depth from the surface, so h is what, re. So re by re is 1. 1 minus 1 is what, 0. So g dash becomes what, 0 at a depth h below the surface of the earth. Is that clear? Now h above the surface of the earth, h above the surface of the earth, अर्थ के सरफेस से h ऊपर, g डैश क्या होगा, दैट विल बी, ठीक से देखना, इट इज g 1 minus 2h over re if h is very very small compared to re. Suppose the radius of the earth is 6400 kilometers. अर्थ की रेडियस है 6400 किलोमीटर्स है, एंड यू वांट टू फाइंड द वैल्यू ऑफ g at a height, suppose at a height 100 meters above the surface of the earth. So 100 meters is very, very small compared to radius of the earth, then this equation will be valid. In case h is appreciable, तो फिर g dash क्या होगा? G dash is equal to g upon 1 plus h over re whole square, 1 plus h upon re whole square if h is not very small compared to re. h अगर re से बहुत छोटा नहीं है, if h is not very small compared to re, तो g dash will be equal to what? G upon 1 plus h over re whole square. This will be the value of what? ये g की वैल्यू होगी अगर आपको h की वैल्यू काफ़ी बड़ी है अर्थ के सरफेस से. चलो, सो यू रिमेंबर दिस. आप जैसे इफ़ यू आस्क मी कि सर वाई यू आर नॉट टेलिंग मी द डेरिवेशन, आपके इसमें जो भी कॉम्पिटिशन्स हैं देयर इज़ नो नीड ऑफ एनी डेरिवेशन, नॉट इवन नाउ. मतलब अभी नहीं कि अभी डेरिवेशन ज़रूरत नहीं है. आई एम टेलिंग यू इवन फॉर द IIT JEE और द नीट पेपर ऑल्सो, IIT JEE और नीट के एग्ज़ाम के लिए भी क्या है, डेरिवेशंस की रिक्वायरमेंट नहीं होती है. यू नीड द डेरिवेशन ओनली फॉर द स्कूल कोर्स ड्यूरिंग योर 11th सिलेबस, उसके लिए ज़रूरत होती है. सो आपको भी कॉम्पिटिशन्स के क्वेश्चन सॉल्व करने हैं ऑल, जैसे मैं आपको एक इसमें थोड़ा सा जी की वैल्यू में और वेरिएशन होता है. आई टेल यू दैट एंड आफ्टर दैट आई एम टेलिंग यू इट्स एप्लीकेशन ऑल्सो. लुक एट दिस. You see, I had told you in the circular motion that there is a force called centripetal force and there is a force called centrifugal force. So about the centrifugal force, I had told you that whenever you keep an object on a rotating frame means what? For example, merry-go-round, it's revolving around its axis, it's rotating about its axis, and if you keep a mass on the merry-go-round, if you stand there, you have to hold the rod. If you don't hold the rod, due to the centrifugal force, you will be forced outwards. So that force that forces you outwards is called what? That is called centrifugal force. So what you have to remember, whenever you are on a rotating platform, on a rotating frame means place of observation, you are on a rotating frame, a pseudo force, pseudo means which is not real but that acts, means because you are on the rotating frames you are experiencing that force. But if you observe, if someone is observing you from the ground frame, he will not observe, he will not see any force acting on you. So when observer or the object is on a rotating frame, a pseudo force called centrifugal force acts on the body in the direction away from the center. सेंटर से बाहर की ओर एक फोर्स रहेगा कॉल्ड सेंट्रीफ्यूगल फोर्स. सो दिस ट्रू फॉर द अर्थ ऑल्सो. अर्थ इज रिवॉल्विंग अराउंड इट्स एक्सिस विच पासिस थ्रू द पोल्स. जो अर्थ की एक्सिस ऑफ रोटेशन है दैट ऑलमोस्ट पासिस थ्रू द पोल्स. मतलब एक्सिस ऐसे नहीं होती एग्जैक्टली, इट्स टिल्टेड स्लाइटली, बट वी कैन से ऑलमोस्ट पासिस थ्रू द पोल्स. इट्स रोटेटिंग लाइक दैट. सो ऑन वन हैंड ए मास ऑन द सर्फेस ऑफ द अर्थ इज अट्रैक्टेड बिकॉज ऑफ व्हाट? स्मॉल जी से अट्रैक्ट भी होता है, बट बिकॉज ऑफ सेंट्रीफ्यूगल फोर्स इट विल व्हाट? इट विल ट्राई टू गो आउटसाइड ऑल्सो. ड्यू टू द सेंट्रीफ्यूगल फोर्स ये क्या होगा? ये बाहर की ओर भी जाएगा, है ना. इसके ऊपर एक सेंट्रीफ्यूगल फोर्स रहेगा. सो नेट अट्रैक्टिव फोर्स बिकम्स व्हाट? लेस. सो व्हाट वी से इट लाइक द इफेक्ट ऑफ रोटेशन ऑफ अर्थ on the value of G. So it is what? At a latitude angle lambda, the latitude angle lambda, the value of G will be what? G dash will be equal to G. This would have been the value of acceleration due to gravity. This small g had been the value of acceleration due to gravity if Earth was not revolving. Then this should have been the value. But now because of, if you include the effect of rotation, G dash will be G 1 minus G minus omega square RE cos square lambda. Lambda is this angle. Equatorial line से this position makes what angle lambda? This is called This is called latitude angle. This is the latitude angle. What is omega? Earth के rotation में if it takes capital T time, omega is what? 2 pi over capital T. We call it angular velocity. Angular velocity of Earth. If it is taking capital T time for the revolution, एक rotation में it's taking time t, that is the period of revolution, then angular velocity omega is what? 2 pi upon capital T. R is the radius of the earth. So due to this means where will be the maximum effect of rotation? G dash minimum कहाँ पे होगा? minimum कहाँ पे होगा? At the equator. Equator पे lambda is what? 0 and cos 0 is what? 1. When this term is 1, so from the G you will subtract what? Minus omega square Re. This much is to be subtracted. So this is the minimum value of G. So G dash is minimum where? At the equator. And what will be its value? Its value will be G minus omega square Re. And where will be the value of G maximum? G dash maximum. कहाँ पे? Pole पे. At the pole. Why? Because pole पे there is no effect of rotation. At the pole lambda is what? 90 degree. At the pole lambda is what? 90 degree. In cos lambda is what? 0. So the part which was to be subtracted becomes what? 0. So nothing is being subtracted on account of rotation. So G dash becomes equal to what? G. जो बिना rotation के effect होगा. What will be the value of G without rotation? The same will be the value at the G of the G at the pole. तो पोल पे G की वैल्यू ज़्यादा होगी और इक्वेटर पे G की वैल्यू क्या होगी? कम होगी. Now see if someone asks you that you have to do a business, and what is that business? You're buying something at the equator and selling the same thing at the pole. You're buying something at the equator and selling the same thing at the pole. With what perception? Because the value of G इक्वेटर पे कम है, तो आपने इक्वेटर पे बाई की तो G की वैल्यू कम है, तो तौल में क्या होगा? जो वेट होगा उसका कम होगा, तो वेइंग में क्या होगा? काफ़ी ज़्यादा सामान आएगा. और पोल पे आप उस सामान को ले गए, G की वैल्यू ज़्यादा हो गई तो सामान तौल में क्या होगा? ज़्यादा हो जाएगा. तो इफ़ यू वांट टू डू दिस, व्हाट काइंड ऑफ बैलेंस यू शुड यूज़? देयर आर टू ऑप्शंस अवेलेबल. वन इज़ व्हाट? बीम बैलेंस. बीम बैलेंस आपने देखा होगा, जिसमें क्या होगा? एक और क्या रखते हैं हम? सामान, गुड्स, और एक और क्या करते हैं? वेट. तो आप बीम बैलेंस यूज़ नहीं कर सकते. तो बीम बैलेंस यूज़ करोगे तो इक्वेटर पे आपका वेट भी हल्का हो गया, सामान भी हल्का हो गया. पोल पे आपका वेट भी भारी हो गया, सामान भी भारी हो गया. सो देयर इज़ नो एडवांटेज. सो इफ़ यू वांट टू गेट एडवांटेज ऑफ इट, तो व्हाट यू शुड डू? यू शुड यूज़ द सिंगल पेन बैलेंस. सिंगल पेन बैलेंस मीन्स व्हाट? जिसमें एक पेन होता है. व्हेन यू पुट on the weight on that, so there is a spring inside that spring gets compressed and that gives the reading of weight. So because there is only one pen, so the value place where the value of G is less, इसकी weight की reading क्या आएगी? कम आएगी. When you're buying that thing, that goods, you're buying at the equator, so the value of G is less. ठीक है ना? तो तौल में क्या होगा? उसकी तौल कम आएगी, सामान ज़्यादा आएगा. When you're selling the same thing at the pole, because the value of G has increased, so its weight will be what? more. तो आपको वहाँ पे weight उसका क्या होगा? ज़्यादा मिलेगा. This is about the value of G. अब देखो, when they give you the questions like this कि the value of acceleration due to gravity at the surface of the earth, G at the surface of the earth is 9.81 meter per second square. अच्छा, see this 9.81 is what? अब मैंने अभी आपको क्या था? Right now I told you the value of G at the different places of the earth will be different. The value of G at the equator is different, at the poles is different. It depends upon what lambda. So this value of G 9.81, which is taken to be standard, is what? It's an average value at lambda equals to 45 degree. Where the latitude angle is what? 45 degree. The value of G is what? It is this. So it is only for the academic purpose. Like suppose a book has been written in some part of UK and some student in the India is using it. and when you calculate the answer, you have to use the value of G also. So that book has been written in UK. The latitude position of देख रहा हूँ आ रहा है इसमें नहीं है आ गया ठीक है. So you see there was some problem with the battery. Now you see I continue this. So look at this. जो मतलब someone in India is solving the question. If the student uses the value of G, because the book was written in UK, and if he uses the value of G, what is in India, at that place where he is solving the question, his answer will not match, because the answer would have been given according to the UK. So for the academic purpose, what we do, whether a book has been written in India or in UK or somewhere else, they'll uniformly use what? Every writer will uniformly use what? The value of G, they'll be using 9.81. So everyone at every place will get what? The same answer. Otherwise the answers will not match. So there's the only significance of 9.81. Is that clear? Now see, the question is like what? Question is, the value of G at the surface of the earth is 9.81 meter per second square. This is the value of what? Acceleration to gravity at the surface of the earth. Now they ask you what will be the value of acceleration due to gravity on the surface of a planet, whose radius is twice that of the earth and density is half. उस planet के material की density is what? Half compared to that of the earth, and radius is what? Twice. So what will be the value of acceleration to gravity on the surface of that planet? How will you proceed? You see, for the surface of the earth, G equals to what? Capital G mass me upon what? Re square. I had told you this thing. This is a capital G mass me upon Re square. Now look at this. Let's find what will be the mass of the planet. You see, mass equals to what? Volume into density. Mass equals what? Volume into density. So because radius is what? 2 times. Radius is twice. So volume of the planet will be what? 8 times. Because volume is what? Volume is 4 by 3 pi r cube. Volume of a planet is what? 4 by 3 pi r cube. So cube of the radius. It is what? Cube of the radius. So if radius is 2 times, radius is what? 2 times. So volume will be what? 8 times. So mass of the planet becomes what? Because of this factor, it becomes what? 8 times. 8 times of the mass of the earth, because volume becomes 8 times. But density is what? Half. So volume into density. So due to density, the mass of the planet will become what? Half. Could you understand this? mass of the planet is, volume of the planet is what? 8 times. So due to that, volume is 8 times, density is half time, volume into density is what? Mass. So mass will be what? 8 into 1 by 2 times of the mass of the earth. So that will be what? me by 4. This will be what? It will be mass of the planet is me by 4. I'm sorry, yes, into half. So that is what? me by 4. Now we write for that planet. This for the earth G, for the planet GP, capital G. In place of mass, you will keep what? Mass me by 4. Now radius. In place of radius, you will write what? 2re. 2re. So 2re square means what? 4re square. This will be what? 4re square. Now we divide this equation from this equation, so we get G equals to GP, G upon GP. Capital G will be cancelled, mass me and me will be cancelled, re square and re square will be cancelled. So this becomes what? 16 upon 1. This 4 into 4 will go up. So that is what? 16 upon 1. That means GP is equal to G upon 16. This will be what? G upon 16. Is that clear? Could you understand this? Look at this. Because this becomes what? Achha, this has become wrong. This is what? 4 times. I'm sorry. This is what? 4 times of the mass of the earth. 4 me. Is that clear? This is what? 4 times of mass me. So this is what? Not upon 4, this into 4. And in place of radius, you'll write what? 4re square. So 4 and 4 gets cancelled. So by the way, this comes what? GP is equal to what? G. GP is equal to what? G. ये दोनों आप देखो इक्वल आ रहा है. कैपिटल जी एम ई अपॉन आर ई स्क्वायर, कैपिटल जी एम ई अपॉन आर ई स्क्वायर. सो जीपी इक्वल्स व्हाट? जी. दैट मीन्स की द acceleration to gravity on the surface of that planet is also what? 9.81 meter per second square. Is that clear? So this is how that you will solve these kind of questions. Means they'll describe another planet, they'll take the density of the planet different, they'll take the radius of the planet different, then you'll have to compare the acceleration due to gravity on the surface of that planet and on the surface of earth. So you'll write the equations like this. Means depending upon the radius and density, you'll calculate that mass of that planet is how many times of the mass of the planet of the earth. In radius re square, so here re by 2 etc, whatever it be, accordingly you write that. Is that clear? So this becomes, because radius is 2 times, so it becomes 2re whole square, so that is what? 4re square. Mass is also 4 times, so 4 and 4 get cancelled and you get the same value of G on the surface of that planet also. So this is about the variation of acceleration due to gravity on the surface of Earth or any other planet. Now look at this. Now see, there is a term we call it gravitational field intensity. See, gravitational field intensity is what? We define this term as gravitational field intensity. Before that, there is a term gravitational field. Gravitational field is what? You see, in the surroundings of a mass, up to certain region, another mass, if it is kept, it will be attracted towards it. This is a mass m. If in its surroundings, you keep here a mass m, this is a mass m. If in its surroundings you keep a mass m dash, and the mass m dash is attracted towards a small m, we will say that mass m dash is inside the gravitational field of m. Then the mass m dash will be said to be inside the gravitational field of mass m. So that means gravitational field is the region surrounding a mass up to which its influence is felt by some other mass. Is that clear? So the whole of the area up to which its influence will be felt by some other mass that area will be called its gravitational field. So the other mass will experience its influence in what form? In the form of force. Like force, attractive force will be acting on it. That means it is inside the gravitational field. If you keep here mass m dash, but no attractive force is acting on it, you'll say it is out of the gravitational field. This is what? Out of the gravitational field. So what happens that in the surrounding of a mass up to certain distance, its gravitational field is present. Beyond that, no gravitational field is present. Beyond that, usually the gravitational field is not present. There is a gravitational field. So similarly, there is another term, that is what? Gravitational field intensity. You see the other term is what? It is the gravitational field intensity. You see the gravitational field intensity is what? Gravitational field intensity at a point inside the gravitational field is the force acting on 1 kg mass at that point. What is the meaning of it? Suppose you have a mass m. You have a mass m. Now, at a distance r from it, at this point you want to know what is the gravitational field intensity. It's denoted by capital E. Due to this mass, inside its gravitational field at a point P, some gravitational field intensity will be present. And what will be that? If you keep here 1 kg mass, what will be the force acting on 1 kg mass will be called gravitational field intensity. So see, if I keep here 1 kg mass, the force acting on will be capital G, m, m1 into m2, m2 is what? 1 upon what? R square. And this is called gravitational field intensity E. So the formula for it becomes what? The gravitational field intensity due to a mass at a distance r from it will be capital G small m upon what? R square. And why do we find the gravitational field intensity? We find the gravitational field intensity because of this general pattern. It's a vector quantity. Achha, what becomes its unit? Its unit becomes Newton per kg. Why Newton per kg? You see the unit of capital G m1 m2 by r square is what? Newton. Whole, there is a force, its unit is what? Newton. You are finding force on 1 kg mass, so that is what? Newton per kg. And it's a vector quantity. This is a vector quantity. So if this is vector quantity, what will be its direction? At this point, the direction of E will be what? Towards this mass. So there is always 2. At any point, the gravitational field intensity due to a mass is always directed towards that mass. If there is a mass m, if I ask you what will be the gravitational field intensity, direction of gravitational field intensity due to this mass at this point, it will be towards this mass. It will always be directed towards this mass. ये उसी मास की ओर डायरेक्टेड होगा जिसके ड्यू टू आप ग्रेविटेशनल फील्ड इंटेंसिटी यू आर कैलकुलेटिंग. ठीक है ना? नाउ यूल सी, अब आप देखेंगे. सो दिस इज अबाउट द ग्रेविटेशनल फील्ड इंटेंसिटी. एंड व्हाई do we feel interested to find the gravitational field intensity? Because see, for the purpose of competitions, you'll have to keep in mind one thing. You'll remember one thing. If in a certain region there's a gravitational field E, if in a certain region there is a gravitational field E, जैसे यहाँ पे you know कि gravitational field is what? E. If you keep a mass m inside it and a mass m is kept inside it, it will experience a force F equals to m into E. Means if I say, when I say gravitational field intensity E is present here, means this gravitational field intensity E must be produced because of some other mass. There might be some mass in its surroundings. There must be some mass in its surroundings which is producing the gravitational field intensity here. And inside that gravitational field intensity, you're keeping a mass m. So the force acting on it will be what? M into E. And what will be the direction of force? Direction of force will be towards E. The direction of force will be same as the direction of E at that point. Will be same as the direction of E at that point. Is that clear? Do you understand this? This is clear, no? Now see. So this is about the gravitational field intensity. Now we have another definition here. We call that gravitational potential. So you see, gravitational potential, I'm telling you only its formula because the definition is not that much needed. In any calculation it will not be needed. That is what gravitational potential due to a mass m at a distance r from it at the point P, the gravitational potential V will be minus of g m by r. Just for the sake of your knowledge and for your curiosity, I tell you one thing, what is the meaning of because see, in this way, when I tell you a term, I don't tell you what is that term, you become curious to know what is that term, what is the meaning of the term. So I tell you that gravitational potential V, the equation formula is what? At a distance r from it minus gm by r, it will always be negative. It will always be what? It will always be negative. One thing. Second thing is what? Second thing is, this is something related to the energy. It is related to energy or work. Basically, when we carry a 1 kg mass from infinity up to this point, when we carry a 1 kg mass from infinity up to that point, how much work is needed? That work is called gravitational potential. So that means its unit, it's a scalar quantity. It's a scalar quantity. It's a scalar quantity and its unit is what? Unit is joule per kg. Its unit is what? Joule per kg. जिसकी unit है, that is what? Joule per kg, because work done to carry 1 kg mass. So this is what? Joule per kg will be the unit, gravitational potential. And why I am telling you the gravitational potential? Because when there is a system of two masses m1 and m2 separated by distance r, when there is a system of two masses separated by distance r, m1 and m2, then there is a gravitational potential energy, gravitational potential energy of the system, and that equals what? Capital G m1 m2 by r. This is the, and this also, this is always negative. Gravitational potential energy of the system is always what? Negative, and that is what? Minus capital G m1 m2 by r. This is the gravitational potential energy of the system. Is that clear? So in my today's class, I have covered the basic definitions of the chapter. Gravitational field intensity, gravitational potential and all. Now there are applications like what? How is the motion of a satellite around the earth? What will be the velocity of the satellite? What will be the period of revolution of the satellite? What is the meaning of equatorial satellite? What is the meaning of polar satellite? What is the meaning of geostationary satellite? Geostationary satellite. What is the meaning of escape velocity? So all these are applications which are based upon all these terms, which I have the fundamental laws and the definitions which I define right now. They're all based upon that. So in my next class, I'll take up the class of its applications. So alright, you'll revise all these terms When you know all these terms, you'll understand the application part very well.